All right, some students asked me to talk about the halfway point, which is related to problem number 5. And in problem number 5, we're trying to find this maximum altitude. And the maximum altitude happens, as I said, halfway through the problem. But it also happens when the final y velocity is 0. Now, by final, I mean final by stopping the problem at the halfway point, not waiting for it to hit the ground. But I'm here to tell you that this halfway problem is much easier to solve if you do the original problem, classic number 2.
Okay, goodbye.
See ya! Where the launch velocity is like this and the object goes all the way to the ground. So if you solve this problem first, then for the halfway problem, you have to solve for the maximum altitude, y max, by doing a trick. But you can get the time by saying it's the time from the whole problem divided by 2. And you can get the distance where this occurs by saying it's the distance from the whole problem divided by 2. So by doing the whole problem, you get a lot of stuff. You just have to solve for the maximum height by setting the final y velocity equal to 0. So let's look at the initial setup, the setup for this problem, and let's be specific. This is the Count de Monet problem, where the initial velocity is 450 meters per second, and the launch angle is 60 degrees. If that's true, then the initial x velocity is 450 times the cosine of 60 degrees, and it's half of that, which is 225 meters per second. And the initial y velocity is 450 times the sine of 60 degrees, and that's 390 meters per second. So for the whole problem, if we fill out the list of knowns and unknowns, x will be, dunno, y will be 0, VIX will be 225, VIY will be 390. Did I say 360? Wow, I think I misspoke. VFX will still be 225. VFY, well, it'll be minus 390. And AX will be 0. That's why these two are equal. And AY will be negative 9.8. Let's put the units in here. There we go. And the time, we don't know. And you know how already to solve the y equation to find the time, and use the time in the x equation to find x. Now when you want to solve the halfway thing, the halfway problem has a different list of knowns and unknowns. For the halfway problem, x is, I don't know, but it's half of this x, because we talked about that before. Y is, well, y is the maximum y. Y is the altitude. Y is the maximum height. VIX doesn't change, 225 meters per second. VIY doesn't change, 390 meters per second. VFX doesn't change, it's still 225 meters per second. That's because acceleration in the x direction is 0. But VFY does change when you stop the problem at the halfway point. This becomes 0. That's really important. Acceleration in the y direction is still negative 9.8 meters per second squared. And the time, well, we could claim we don't know it, but it is half of the whole time. You see why I say solving the whole problem first gives you so much information over here? But from this information, even without this time and this position, we can find the maximum height using the no time equation. Because see, over here on the y side, we have everything but the time. Well, okay, you're right, we don't have this one, but we're looking for that one. So we just have to avoid time. So VFY squared equals VIY squared plus 2 times AY times Y. Now VFY is 0, that came from here, and we have to square that. Okay, I know that's ridiculous, but I'm a creature of habit. This is 390 squared, and this is plus 2 times negative 9.8 times Y max, whatever that is. So this is going to be a negative term, and this is going to be a very large positive term. I would bring this term over here, and so I would get 19.6 Y max, and that's what 2 times 9.8 is, and then that's equal to 390 squared, and from there I think you can do the algebra to find out what Y max is. Now, one more thing. It's only been 4 minutes and 58 seconds. This problem has very large numbers, and that's because the initial launch velocity is very large. This speed is greater than the speed of sound, and this is a high angle. We're talking artillery here, all right? So the fact that it might go, almost 20,000 meters, that's 20 kilometers, that's, 16 miles. That is not unheard of in terms of artillery, okay? So when you get large numbers for the time and for the maximum height and for the distance traveled, don't worry about it. This is something that's outside of your experience. All right, I hope that helps.